Good morning, everyone. Today we'll speak about balance. So this is like a preview of my sabbatical project. Next semester, I'll start the sabbatical year at the Santa Fe Institute. The main plan is to write a book on this topic on balance, which tries to be a synthesis of several concepts related to complex systems. So I'll tell you like the outline of it. And we'll go a bit deeper into the first chapter, which are like historically related concepts. So the main premise is that we can say that everything tends to a balance, in the sense that, well, it's almost a tautology, because we can say that if something is unstable, then it's extreme, and something that is stable, then it's usually between, let's say, more than one condition where the system is not stable anymore. So it's a bit of a tautology to speak about balance, because that's how we call the states that systems naturally tend to, which is similar to the tautology we have discussed, that systems tend to their more probable state. And it's a tautology because we define probabilities precisely in such a way. So we call something balanced in a way after we observe that it's already stable. But I think it can be a useful description to bring together several concepts that we have seen already along the course, such as complexity, emergence of organization, and slower is faster effect, heterogeneity, and more. So we spoke about the age of chaos. The main idea is that in dynamical systems, you want balance between robustness and adaptability, between order and chaos, between stability and change. As Monod would say, between chance and necessity. Well, necessity would be the order, chance the chaos. But we see several historic examples in myths and philosophy from antiquity. Perhaps the most famous is the myth of Icarus. If you remember, his father Daedalus in Crete made some wings, but he warned his son Icarus not to fly too high, because the sun would melt the wax, not to fly too low because the foam of the waves would be would swallow him. And of course, he didn't listen to him, flew too high, wax melted, and he fell to his death. So I mean, we can interpret that as a warning to avoid extremes. But in many other cultures, we have similar examples. So in Buddhism, we have the Great Middle Way, or also known as Madhyamaka, proposed mainly by Nagarjuna. And this school of thought speaks about the balance between eternalism, which would be something like Parmenides in ancient Greece, speaking about some things that are and don't change, and nihilism, that we could call something ephemeral, that things are changing constantly, so then we have nothing to grasp. So if we go to those of both extremes, then we run into trouble. If we assume that nothing changes, then why should we worry? And if everything is changing constantly, why should we care? And of course, well, there are also modern versions of this, well, existentialism, and also modern nihilism, which in this way it's different from 19th and 20th century nihilism. But let's say we can say that we can find a meaningful life between these two extremes. And this is one avenue that is explored in Buddhist philosophy. In Confucianism and Taoism, there's also the well-known concept of yin and yang, which are opposites that complement each other. So there is dark and light, negative and positive, receptive, active, winter, summer, female, male, disorder, order. And the main idea is that these, well, also life and death, the idea is that when these are opposites, they are not only complementary, but also interconnected and interdependent, in the sense that we cannot go only with one of them, we need the other. Therefore, if we just like one and we don't like the other, let's say it's, I mean, perhaps childish is not the best adjective for this, but yeah, but perhaps naive, because we cannot have one without the other. Like we might like summer and hate winter, but there is no summer without winter. There is no day without night. There is no life without death. So, let's say these philosophies delve deeper into this idea. Also in Greek philosophy, Empedocles speaks about love and strife. In Greek, philotes and neikos. And these are attractive and separating forces of four elements, which, just like in other ancient cultures, they are water, air, earth, and fire. And Empedocles says that everything is composed of these four basic elements, and they are brought together and separated by love and strife, which are like very basic forces. And in some cases, one might dominate, but you always have the other. I mean, you cannot have only love or strife. You always have both in varying degrees. And also in Greek philosophy, in the Philebus dialogue of Plato, there's a debate between the balance between pleasure or enjoyment or delight, say, to live a carefree life, and so-called wisdom or intelligence or memory or prudence. And let's say the conclusion is that either extreme has its disadvantages, so the best combination is a balance between these two extremes. And also, in ancient Greece, there were the oracle in Delphi. There were three maxims that were engraved in stone: know thyself, nothing in excess, and surety brings ruin. So the second, nothing in excess, it's also could also be seen as trying to strive for balance. So I mean, it's something like very prevalent, and there are more examples. So speaking about the golden mean, I mean, nothing in excess was already mentioned in Delphi. There's the myth of Daedalus and Icarus. Cleobulus also speaks about moderation is best. And also we have examples of this balance or golden mean in Socrates, in Plato, and Aristotle. And actually, Aristotle is most famous to speak about the golden mean, but we have also from other cultures examples of something which is known as golden mean, but in a bit different way. In Tamil philosophy in the south of India, there's also something called the middle state, or Tiruvalluvar, and it's known as the virtue of impartiality. It's basically to avoid excess and preserve equity. In Buddhist philosophy, there's also the idea of equanimity, which, I mean, a modern version of equanimity would be the idea of Nietzsche going beyond desire and deception. So in equanimity, in the Buddhist sense, is going beyond attachment and aversion. So we usually are attached to the things we like, and we are averted to the things we dislike. And this creates suffering for us and for people around us. So if we accept things as they are, instead of trying to accept things as we want them to be, Buddhist philosophy tells us that we will be liberated, and that's path towards enlightenment. In Hinduism, there's also the concept of the golden mean. In Judaism, Rambam speaks about the balance between soul and body. Maimonides has this quote: "The right way is the mean in each group of dispositions common to humanity." St. Thomas Aquinas also says, "Moral virtue observes the mean." And in Islam, there are also examples of this balance. In the Quran, they speak about Islamic society or Ummah justly balanced between extremism and sloppiness, which, of course, Islamist extremists seem to have missed. Al-Ghazali said, "What is wanted is balance between extravagance and miserliness, moderation, with a lot of distance between both extremes." So, I mean, these are plenty of examples where you can see that extremes are undesirable. So the best possible state is somewhere in between. But of course, the question is, what's the optimum balance? And I mean, in Mexico, we have several common sayings that refer to this: tanto que queme al santo, ni tanto que no la alumbre, or ni muy muy ni tan tan. So it's like common wisdom. More modern examples, there's the so-called Goldilocks principle, and this refers to the children's tale of Goldilocks and the Three Bears. That, for example, this one soup is too hot and the other is too cold, and the other one is just right, and one chair is too high, and I forget about the chairs. But anyway, the beds, one is too hard, the other is too soft, and the other one is just right. So people refer to this Goldilocks principle to many phenomena that seem to be just balanced like that. So in cosmology, there's this problem known as the fine-tuning problem, in the sense that the cosmological constants like gravitational constant, the Planck constant, speed of light, and so on, if they would vary slightly, then we wouldn't be able to have the universe would have with galaxies and stars and planets, and therefore light. So, I mean, there are lots of theories and speculations on why our universe has precisely these constants, this known as the fine-tuning problem. And it's like just the right conditions so that we can be here. And also the distance of our planet from the sun, it's also known as the Goldilocks zone, because if our planet were closer to the sun, it would be too hot. If it were farther, it would be too cold. So the argument is that life is possible just, let's say, in a tight, in a narrow zone, which is where our planet is. I mean, it would be interesting if we found life in Mars and Venus, and then we would need to revise this idea. No? But anyway, in developmental psychology, there's also the idea that babies, in order to develop, need to be stimulated but not overstimulated. In economics, also, there is, well, Goldilocks conditions in economics refer to balance between different market extremes that promote growth. In communication, we have a balance between redundancy and clarity. So if we want to transmit a message with high fidelity, meaning that no information is lost, then we would start adding redundancy. So if some bits are lost, then we have several copies, and then we will know what's the real message. And for example, plants use this mechanism because they have several copies of their genes, and they have many plants have huge genomes because of this redundancy. So it seems that's why one of the reasons why many plants can have developmental paths much more flexible than animals, in the sense that if you take a cell from a carrot, either from a root or from a leaf or from a stem, you can grow, and under the right conditions, you can grow a new plant from that. And in most animals, if you take a skin cell or a bone cell or a blood cell, you cannot make an embryo out of that. But recently, with genetic engineering, people have managed to do so, but it's not trivial. Well, just with 4 mutations. But anyway, the idea is that, going back to communication, is that too much redundancy might be desirable, but it's also expensive in the sense that you need more time or material to transmit this redundant information. So there's another incentive for being as concise as possible. But if you are minimally concise, if there's a minimal error, then you will lose your message. So that's why there's this balance between redundancy and conciseness. And information theory can be used to calculate what will be this optimum balance given the noise in a communication channel. In machine learning, I mean, people also speak about Goldilocks as the balance between exploration and exploitation, in the sense that, let's say, you can see many algorithms of artificial intelligence as search. So if you are searching for a solution, you can have an exploration in breadth or depth. So breadth will be exploration. So you kind of seek different alternatives, and depth would be exploitation. You already have some alternatives, and then you try to go deeper into those alternatives to see whether you can exploit them or find better solutions from that region. And also, there's this idea of flow in psychology, which was proposed by Mihaly Csikszentmihalyi. And he was interested in when people are happy or satisfied. So, I mean, he made some studies where people, I think it was his students, they had an alarm, and when the alarm rang or a beeper, they had to write what were they doing and how were they feeling. And from this data, Csikszentmihalyi generalized the notion of flow, because he realized that people were feeling best when there was a balance between their abilities and the challenges that they faced. And this has been tried to apply in education. So if we go to school and what we are taught is too difficult for us, we get frustrated and we won't learn. But if it's too easy, we get bored and we don't learn either. So we are so-called in the zone when there's this balance between, or a matching between the challenge and our abilities. And this can also be seen in video games, and well, in sport as well, where you are pushing yourself to the limit and you can go just a bit above your limit. I mean, if you push too hard, you will break. So of course that's not desirable. But for example, when you are breaking your own record or your personal best, you have this feeling of flow when, let's say, everything just happens not necessarily without effort, but just falls into place. So in psychology, I mean, this is an active area of research, and we could see it as a particular case of balance. So we already mentioned this idea of the age of chaos and complexity. This was developed at Santa Fe Institute by Chris Langton and Stuart Kaufman and several others. We can see this as a generalization of chance and necessity by Monod, which he published his book in 1970. So we can see this balance between order and chaos as a type of balance. But also we can have other examples of balance which are beyond phase transitions and criticality. So if you remember, with random networks, we saw that there is the order phase, a chaotic phase, and the phase transition. There is criticality, and Perback and others have studied self-organized criticality. Also, Giorgio Parisi, who received Nobel Prize in Physics last year for his work on complex systems. But there's also several other examples about phase transitions in physics. So in fluid flow, we have transition between laminar flow and turbulent flow. And near this phase transition, there's some critical-like phenomena. And similar transition is observed in vehicular traffic between free flow and congested traffic, and in crowds as well. So, I mean, there are plenty of examples that can be described in terms of balance. And another concept that we already saw can be described in terms of balance is antifragility, in the sense that we can see antifragility as a dynamical balance. So just to remind briefly, something fragile is something that gets harmed by perturbations or noise. So Taleb speaks about, as an example, Damocles' sword. So any small perturbation will make the sword fall, and say that would be the end of Damocles. Resilient would be a phoenix, meaning that if it gets killed, it just gets reborn again. And antifragile would be the hydra, in the sense that if you chop off a head, two will grow. So actually the perturbation benefits the hydra, it makes it stronger. And I mean, we know that complex systems tend to a balance between robustness and adaptability, but at the same time, they should resist perturbations and also changing phase of perturbations. But when you have antifragility, you have systems that actually benefit from perturbations. And a question is what to do when the balance or when the optimum balance is moving. And of course, you need adaptation. And some insights we've gained with our work on random Boolean networks and trying to measure their antifragility, and also in genetic regulatory networks and measuring their antifragility, is that the so-called optimal antifragility will depend on how noisy the environment is. So the precise balance between robustness and adaptability will depend not only on the system, but on its environment. It makes sense that if the environment is more noisy, then the system should be more robust. And if the environment is less noisy, then the system can be, let's say, closer to criticality. And let's say, if you go, what we found is that if you go more into the order regime in a system like a random Boolean network, but your perturbations are such, well, environmental perturbations are greater, then that will kick your dynamics towards criticality. And that's why we call these networks antifragile, because they they become more critical in face of perturbations, and we assume that that's good for the dynamics. But still, it's an open question. How should systems be structured? How should they adapt? How should they behave to maintain this balance? Because at the end, ourselves in our lives, our societies, our organizations, our countries, our planet also is facing shifting balances. And how can we build systems or design organizations so that they can better adapt to these perturbations and can actually perhaps even benefit from them? And another concept that that we already saw here is the slower is faster effect. There's this expression in Latin, festina lente, which is something like speed slowly. In Spanish, we say despacio que voy deprisa. And I mean, we already spoke about several examples of the slower is faster effect, mainly in sports. If you kind of burn out a long distance run, then you will not go as fast as you would if you measured your strength, your energy. But if you measure yourself too much, then also you won't do your best time. So again, we can speak about the balance between those extremes of burning out and doing it too easy that would maximize your performance. And I mean, this has applications for crowd dynamics, for traffic jams, where not necessarily going into one extreme. It's kind of a natural tendency, like, okay, let's increase the speed of cars so that they move faster. And it turns out that actually higher speed limits for high densities generates traffic jams for lower densities. Yeah, I mean, I don't want to repeat the class on slower is faster effect. But I mean, this is also related to phase transitions. We can see the slower is faster effect is balanced between going too slow or too fast. And also, it's interesting to notice that in many cases, this balance is dynamic, just like I mentioned in the previous slide. So it would be useful to understand better how these balances shift in order to build systems that can adapt to this shifting optimum balance. And another related work that I mean, we've had with several colleagues from the Physics Institute has to do with rank dynamics, how different rankings change in time. We also have spoken about this, but this leads us to heterogeneity that can also be seen as balance. So what we observed with analyzing lots of data was that in all the systems that we studied, the top ranks, meaning most relevant elements of systems, either university rankings or sports teams or countries ranked by their economic complexity, or natural systems like earthquake zones. The top elements or the lowest ranked elements, they change slower than the rest. So one hypothesis of why it was that we observed this temporal heterogeneity was that this would give you at the same time this balance between robustness and adaptability that is desirable, as we mentioned, because it gives you a balance. But if you have homogeneity, meaning that all the elements of a system change at the same speed, then you need to narrow down into this phase transition that will give you the benefits of both extremes. However, what we well, one hypothesis that we are beginning to explore and find positive evidence for it. One hypothesis of why we observe these heterogeneous dynamics is that heterogeneity would give you criticality for free, in the sense that if you have slower elements, this will be robust, and if you have faster elements, this will be adaptable. So even if you are not precisely in the phase transition with heterogeneity, we assume that you will have critical-like dynamics. So using random Boolean networks, we began studying heterogeneity of structure, which this has been already studied in network science, temporal heterogeneity with Fernanda Sanchez-Puig, where different nodes are updated at different speeds. With Amaury, we're exploring functional heterogeneity, meaning that some nodes have more functional bias than others. And the preliminary results show that each of these enhances criticality in a different way, in the sense that if you have all three heterogeneities, you have even more criticality than if you have just one or two of them. So this is interesting because this suggests that if we have heterogeneity, or if we want a system to be near criticality, it's not necessary to find a phase transition. Moreover, this phase transition is shifting, but just if you have heterogeneities, this will kind of push the dynamics towards criticality, dependent on where in the parameter space you are. So this suggests that criticality is much easier to find by evolutionary search if you allow for heterogeneity. So that's something interesting. And of course, we can see each of these as different types of balance. And I mean, this is also related to this balance I mentioned of search between exploration and exploitation. It says that robustness is basically exploitation and adaptability exploration. Yeah, robustness is exploitation, let's say, to keep the things that work, and adaptability is exploration, to try to find new things, and maybe they will work better and maybe not. But since you want to keep previous functionality, you want to keep what is already working, you need certain robustness. Otherwise, in your exploration, if you explore too much, you will lose information that was already useful. And then you'll need to start again. And from an evolutionary perspective, balance will offer several advantages. And of course, there are different mechanisms that can lead to a balance. But from what we've seen, it seems that balance and complexity should be expected in the evolution of our universe and our biosphere. So it makes me think that, I mean, we're not a lucky accident in our universe, but that we should expect life and intelligence in other planets simply because that's the tendency of the universe. I mean, there's this idea that the universe tends to maximize entropy, but there are several forces that balance that tendency. And I mean, this is organization. And of course, life organizes matter and energy and information far from equilibrium, far from high states. And this makes me suggest that the tendency in the universe is not towards high entropy, but towards balance. And this is related to what we spoke in the class about the loss of information. But anyway, if we understand better the mechanisms that lead to balance, then we should have tools for building more balanced systems at different scales, and also that are aligned better with the natural dynamics of our environment. I mean, it might sound a bit presumptuous to say that this explains why the universe is the way it is. I mean, precisely because, as I mentioned at the beginning, it's kind of a tautology. So how explanatory a tautology can be. I think that in many cases, when we are speaking about general theories that can be applied to everything, I mean, being general, we want them to be applicable to everything. So of course they need to be very broad. However, I think they can be useful because they can give us a better perspective and insights on how to connect existing concepts that have been developed and give us a better perspective of our place in the universe. And also can help explain evolution using minimal presuppositions, can be useful for the fine-tuning problem. And at the most general level, we can also explain different probability distributions as a result of different types of balance. And yeah, I would say that entropy maximization is just one type of balance. And in some conditions, the universe tends to it, but more generally, the universe tends to balance. And then something that can also be explored, the philosophical implications of this general theory of balance, particular towards epistemology. When is it useful to describe phenomena as balanced? And also ethics, how should we behave taking into consideration the concepts of balance? Or why should we strive for balance? Should we kind of put it as a goal in our societies? Okay, we need to be more balanced. How can we measure this? What would be the advantages of using the balance narrative? Can understanding balance guide our behavior ethically? Another question is whether if we understand better ethics, probably we will be able to deal with ethics in artificial intelligence better. Also, we need to realize that we cannot speak about a single optimal balance, but we have diverse balances that are more appropriate for different contexts. So, for example, the balance between experience and learning changes constantly through our lifetime. Babies learn a lot and have almost zero experience, and the elderly learn much less, but they have acquired most experience. So of course we want to have both, but the optimal balance is not like, okay, at this age you are perfectly balanced, and before you are too young, and afterwards you are too old. The balance that you have with different degrees of adaptability or learning ability and experience is shifting constantly, but each of these points has its advantages and disadvantages. So, well, it is known that teams are more efficient if they have a combination of people with different ages, precisely, well, they are diverse in general, but this includes age diverse. Okay, so this is like the outline of the book. The plan is to expand each of these concepts in a chapter, which would be a lecture that I will give at the Santa Fe Institute, more or less each month. So if you have any comments, suggestions, complaints, please feel free to express them. Yes, Elio. Yeah. Yes, Elio. You're muted. Someone else? For LFU, I mean, we can't hear you, so maybe you can. Oh,
thank you.
Yeah.
Yeah, thank you. Yeah, I was thinking in the analogy of exploitation versus explorations with
Yes.
robustness, with flexibility. Because I think that I have saw it in the hurricanes that the density distribution have two peaks is bimodal. In some ways, there is few hurricanes that are intense, the high category hurricanes, and most of the hurricanes are low intensity. Then it's something like that's also appear this dichotomy in the hurricanes. That's just my idea, what do you think?
Yeah, but you said that the distribution is bimodal and not scale free, meaning that there are no intermediate size hurricanes, or that they are less intermediate.
No, it is not scale free. There are clearly it's bimodal.
Yeah. Yeah, that's interesting. I don't know why could that be? Yeah.
Yeah, as an example, in the male and female height or weight, you can saw the same, two peaks. Yeah. The same happened in the hurricanes.
And do you know whether there's some geographical correlation in the sense that the bigger hurricanes tend to be more in particular parts of the planet and the smaller ones in other parts, or like?
So in this case, it's just all the energy. No, is not for all the trajectories along the year.
Yeah,
then it's not for all the region, for all the area. No, it's not. I am not making any spatial correlations. What I am doing is comparing the total annual energy in each basin.
Yeah. I don't know why might that be. I'm sure many people have been working on that, and there are some theories on why.
No, in fact, in hurricane area, people is not using the approximation of complex systems. There is only a team in Europe called CAFE, but they are more focused to use something like neural networks and things like that to make forecasts, but not to understand the nature of the phenomena. They are interested to forecast, not to understand.
Yeah, I guess that if we had data from other planets, then it would be useful. Yeah, but maybe computational models could. Yeah, I don't know how realistic they are in order to be able to explore hypotheses with them. In the sense that, I mean, to answer whether these bimodalities a result of some peculiarities of our planet, or is it something more general that has to do with some scales in physics, like, so for example, in astronomy, there's this Chandrasekhar constant, I believe, or maybe it's not that constant, but well, there's like a mass of the star, and if a star has a greater mass, then it will become a black hole, and if not. So I don't know whether something similar, that if you have like in a region something like potential energy, then this will lead you to a high intensity hurricane, and below that it will converge to a smaller intensity. And even when you have variations in the intensity, for some reason, let's say there's a lower probability to have intermediate intensities. Yeah, I don't know.
Yeah. I was thinking that each mode, each peak represents one phase of the system.
Maybe, yeah.
Okay, thank you, Carlos.
Yeah, maybe you can also see it as attractors, in the sense that, let's say some.
Yeah, in fact, that is true. There are attractors, because we made the return map, the Poincaré map of the time series, and clearly appeared two attractors, and the center of that attractors correspond to each peak.
Yep. Okay. Yeah. Yes, Amaury.
Well, first of all, congratulations in advance. I'm sure it will be a great book. And actually, this all remind me of Wheeler's perspective, who was a physicist who claimed that the whole universe is information. And for Wheeler, the secret of order in the universe, this fine-tuned version that you mentioned, where a small change, like in the radius of an atom or the mass of a particle, can change everything in the universe, is the observer himself. A few months ago, I read a review in Quantum Magazine about a new approach called constructor theory, which, as I understand, is a way to restrict the space of possible universal laws in the universe. And the question is if you know any other approach to solve this kind of dilemma, and how this idea of balance can prove that the universe is self-sustaining.
Yeah, actually, just yesterday I was listening about constructor theory in Lex Friedman's podcast with Lee Cronin and Sari Mary Walker. I mean, I haven't finished, but from what I understand, it's also resonates with what we spoke about, the loss of information. But they have a physicalist perspective, so they start with matter. But let's say they have information in there from the start. And sorry, could you repeat the question about our universe?
Yes, of course, if you know any other approach, like this constructor theory, and how this idea of balance that you mentioned can prove that the universe is self-sustaining.
Yeah, what do you mean by self-sustaining?
Well, for me, it means that there is no like it's not there is no any intelligence, you know, like a god or something like that.
Yeah, I think I forget who asked. Somebody asked a physicist, but I can't remember whether it was Leibniz or Newton or someone else. Like, and where is God in all of this? And the reply was, I don't need that presupposition or premise or something like that. Yeah, I think that with this, but also with other theories, one of the goals is try to understand how the becoming of the universe is self-contained, in the sense that we don't need to come up with explanations that don't have explanation themselves, but try to have minimal assumptions and assumptions that are kind of easy to accept. And well, that's the thing with tautologies. I mean, you have to accept them because they're tautologies. But then they can give you a narrative to understand why the universe is the way we observe it. So I think there might be other theories, similar ones, but in cosmology, this tends to be packed with high-level mathematics, so very few people understand them. So then it's difficult to say much about them. And also, in many cases, they tend to be very abstract. So then it's difficult to apply them to daily life. And I mean, from what I mentioned, having examples from ancient cultures that refer to similar notions of balance suggests that it's something not only prevalent but useful. And also the idea of deriving epistemology and ethics from this, it's kind of also with purpose of having applications in that direction. Not just like, oh, I have this idea and that's it.
Yeah, thank you very much for the answer. I think we need to address more this kind of philosophical problems using a scientific approach, and I'm sure that complexity is an excellent tool for that. Thanks.
Yep. Sophia wrote that also with students after the first exam, the distribution of grades becomes bimodal, meaning that there's a group of students that fails the test and another that passes easily, or?
Yeah, well, there's a peak around 6 out of 10, and then there is another peak around 9 out of 10. And it's, I don't know if these, this is a thing I have observed, but I don't know if it's true for every course, but I've seen that happen after the first exam, that some students, there is a fat, I don't know how to call it, like a wide peak around 6 or 5, and then there is a smaller peak around 9 or 10.
Yeah.
I found it funny because it's like what Elio said about the hurricanes.
Yeah, but these are the grades about an exam or about the course?
The students, the students' grades in partial exam.
Yeah. I mean, with a PhD student, we are analyzing some data of it's like a preparatory course for students who enter the Open University here at UNAM, and there is just one maximum around 8. But yeah,
that's funny.
Yeah, it might change with the exam or how you grade it, or well, you could say you have another peak at MP. Those who didn't present the exam, that's like half of the students. Yeah. Okay. Any other comments? Okay. For next class, I wanted to discuss about violence towards women in Mexico in particular. So I will post a link to an article which was published today in Reforma, where I discussed briefly these ideas. But the idea is that on Thursday we should discuss these ideas and go further and try to come up with solutions following the Soviet books, who's guilty and what to do. So, I mean, it's a very short article, so it's not necessarily to, I mean, it won't be a homework, but if you read it, then we'll have a more interactive class. So be ready to participate on Thursday. Yeah. Okay, so in principle, the last class would be like in a month, I think. Yeah, the 26th. So we have, including this week, 5 weeks. Then the 5th of May will be a holiday. But then probably your final projects should be delivered the 9th of June. I'll double check on that, which is a Thursday.